Hello, my name is Benjamin Martin with the Secretariat of the Global Ocean Resource and Energy Association Institute, also known as GOSI, here on Kumijima in Japan. My talk is Energy, Food, and Water Self-Sufficient Area Project on Kumijima. We appreciate your participation in this workshop and for supporting the Hawaii-Okinawa Clean Energy Partnership. You may have heard recently that Japan has announced a policy shift, aiming for carbon neutrality by 2050, a more aggressive goal than the previous 80%. In addition, on December 9th, the electric utility in Okinawa, Okinawa Electric Company, became the first electric utility in Japan to announce a goal of zero CO2 emissions by 2050. Despite its current high reliance on fossil fuels, these two announcements highlight a shift in sentiment and policy in Japan. On Kumijima, the local town government in 2020 has established its own energy vision, setting a goal of reducing fossil fuel consumption to zero by 2040. The vision calls for meeting this goal through increased renewable energy such as solar and OTEC, as well as through energy storage such as EV. The proposed large-scale ocean water intake project would include a 1,000 kilowatt class ocean thermal energy conversion (OTEC) facility, which would be responsible for roughly 15% of Kumijima's electricity supply. As you can see in the graph on the right, the types of analysis included in this vision also consider OTEC. For the model area, OTEC may provide advantages in addition to increasing self-sufficiency, such as increased marketability for products produced with clean energy. As a step towards increasing clean energy on the island, which is currently about 5%, and has been inhibited by the islanded grid capacity for intermittent energy sources, Kumijima Town has applied for a project which will enable installation of solar photovoltaic panels and storage batteries at the island's two junior high schools. The dramatic decrease in battery cost has provided an opportunity for the island to increase clean energy while limiting the disruptive element to the local grid. The project plan calls for 42 kilowatts of panels, with 44.8 kilowatt hours of storage. The setup will also improve disaster response by providing small-scale power during outages or disaster situations. This project will bring a total of 44 kilowatts of renewable energy to Kumijima Town. To provide a better understanding of why Kumijima is developing a model area, we would like to provide background on the current situation in Japan and Kumijima. Currently in Japan, there are 15 sites utilizing deep ocean water, or DAO, from Hokkaido in the north to Kumijima in the south. Each facility has its own focus, but overall, Japan has expertise in utilizing many aspects of the DAO resource. DAO is water found below 200 meters, a depth below where sunlight permeates. This, as well as other ocean mechanics, provide DAO with properties different from surface seawater, namely low temperature, such as about 4 degrees Celsius, colder than some refrigerators, cleanliness, very little bacteria can survive cold temperatures, and the natural thermocline help keep human pollution away, and nutrients. Naturally occurring nutrients are normally consumed by plankton in the surface area, but remain in the deep water. The nutrients can be used like fertilizer in aquaculture. Okinawa's Deep Ocean Water Research Center, ODRC, is located on Kumijima, and since 2000 has supplied up to 13,000 tons per day of surface and deep water for internal research and for use by private companies. The center was developed with a primary focus on fishery, with an intake depth of 612 meters for deep water and 15 meters for surface. The ODRC develops technologies based on DAO properties to support industrial growth. A separate department in Okinawa Prefecture's government also established the Okinawa OTEC Demonstration Facility in 2013. In Kumijima, the majority of water is used by fishery, specifically sea grapes and kuruma prawns. Prawns are developed at a hatchery before grow out in large-scale ponds. In Kumijima, these prawns are highly prized, but were originally wild-caught. However, the trend, which is reflected in other industries, is towards farm prawns. Deep ocean water provides a resource for stabilizing supply, improved profitability, and reduced risk. In particular, the hatchery on Kumijima supports farms throughout the prefecture, enabling a stable and important industry for the entire prefecture. On Kumijima, local companies buy water from the ODRC and use it as a resource to create their products. As with the overall trend, the largest industrial use is for kuruma prawns, which with sea grapes now have the largest market share in Japan. In addition, the local cosmetics company Point Pure continues to grow as it produces its own brand and OEM cosmetics such as shampoos, moisturizers, and cleansers. Together, these industries provide roughly 2.5 billion yen in annual revenue, supporting more than 300 jobs and industries not just on the island, but throughout Okinawa. In addition to producing products for local consumption, it also allows for exports. To give an idea of scale, Kumijima's total agriculture output is about 2 billion yen per year, so Dow Industries have become one of the largest single industries for the island. Here's a quick look at some of the deep-sea water industries on Kumijima. As the current water resource is limited by capacity, several projects over the past few years have taken on advancing Dow use towards expanding intake capacity. These include but are not limited to Saga University's thermal difference desalination experiments, General Oyster Farm's research and hatchery development, Coral Nursery, Kumijima Town's cooled soil agriculture, and the Okinawa OTEC demonstration facility. The Okinawa OTEC demonstration facility, established in 2013, uses the temperature difference between surface and deep water to produce clean electricity. This is achieved in a Rankine cycle, which uses a low boiling point working fluid. For this facility, R134A, a refrigerant commonly used in air conditioners and refrigerators, is heated in a plate heat exchanger by the surface ocean water. Once warmed, it vaporizes. The vapor expands and a turbine spins. The turbine drives a generator which then produces electricity. The gas leaving the turbine is cooled back into a liquid in a second heat exchanger, where deep ocean water provides the cold energy. This process can operate continuously, allowing for nearly 24/7 power generation. Okinawa's demonstration facility is 100 kilowatt, about the scale needed for 250 households. In Japan, our future goal for OTEC is a large-scale offshore facility. To reach that goal, developers consider the next step to be a megawatt-scale onshore OTEC facility. To establish this facility, expanded ocean water capacity is required, which matches well with the local fishery and other industries' demand for more ocean water. Recognizing the need for expanded ocean water capacity for both Dow Industries and OTEC, the feasibility study conducted in 2010 proposed the Kumijima model. The Kumijima model is a concept for adapting current Dow use into an advanced, self-sufficient system. So far, local industries rely on island utilities for water and power. However, the model calls for a more advanced, self-contained system that would allow for multiple use of the Dow resource while also supplying energy and water needs to industries. The current ODRC is located in the northeast of Kumijima, with several local industries nearby. There are, however, areas available for expansion, such as the blue area for fishery and green for agriculture. New large-scale intake would provide resources for expanded agriculture, aquaculture, and other Dow use industries. Okinawa Prefecture in 2016 promoted the start of multiple use of Dow by connecting the OTEC demonstration's ocean water to local industries. This provided useful understanding of the needs, challenges, and know-how for post-OTEC cascade use. As an example, in the case of sea grapes, they mix surface and deep sea water to maintain a desired temperature. However, in the warm summer months, post-OTEC surface water provides the correct temperature, allowing for reduced Dow consumption. In 2017, an economic survey was carried out to consider the costs and benefits from expanded ocean water intake, focusing on fishery. OTEC's costs and benefits were excluded from the analysis, and intake distribution and OTEC will be developed in parallel but separate projects. The results of the study were positive, with a benefit-to-cost ratio over the study's scope of more than 2. We would expect OTEC to improve this further. In fiscal year 2020, further hearings have been carried out to more accurately quantify the potential for water use in industries, as well as take into account new potential uses and users. The next step towards expanded intake is a detailed site survey planned for fiscal year 2021 to 2022. Although the general area for expanded use is generally defined, detailed survey of land and sea are necessary to determine intake positioning and design, which will have a large effect on the overall project. This survey is planned to begin April 2021. The outcome of this work will be a detailed plan for the establishment of the Kumijima model and act as a precursor to necessary environmental impact assessment, detailed design, and construction of water intake and distribution lines. Thank you for taking the time to listen today. I hope the information was interesting and useful, and we look forward to you visiting us here on Kumijima.